Toydale online class, we got you. Wherever you want it from, we got what you need. Toydale online class, we got you.
Good day, everyone. Once again, you are welcome to Toydale online class. Just as I've introduced the set of numbers, so the first set of numbers, the first set of numbers are called the natural numbers. The natural numbers. So denoted, this one is denoted as n, as we have it on the bottom. Good day, viewers all over the world. You are welcome to Toydale online class. So we want to look at the derivative of a product. That is, if you have two different functions, product of two different functions, the function can be one can be polynomial, the other one can be exponential. But if you have the product of two different functions, how do we take the derivative of that function? That is what we are about to discuss. So in this case now, if there are two different functions, u and v, we represent the function as y is equal to u multiplied by v. Then the derivative of that function will be given as the y dx, which is the derivative of the function, will be given as, we first pick the first function, u, then we differentiate the second one, the v dx, where function u and v are functions of x, plus we now pick the second function now, v, we now differentiate the first one, du dx. And that is how to take the derivative of the product of two functions irrespective of the function. You know, as I've said earlier on, the function, we have so many functions in mathematics. We have transcendent functions, exponential function, logarithm function, logarithmic function, trigonometrical functions. We have so many functions. But irrespective of that function, if you have the product of two functions, then this is what we are expected to do if you want to get the derivative of that function. So please, let's note that if you have the derivative of if you want to take the derivative of two functions, we first pick the first function, we differentiate the second one, plus we now come back and pick the second one, we differentiate the first one. So I decide to write u dv dx plus v du dx. You might decide to say pick the v as the first one, v du dx plus u dv dx. At the end of the day, we are still going to get the same answer. So under product rule, derivative of a product or product rule, arrangement does not really matter. So arrangement does not have any effect. So let's take example. Find the derivative. Find the derivative of each of the following. So let's take 2. Y is equal to, let's say, x squared into bracket 1 plus x raised to power 3. Then b, let's say we have maybe y is equal to 4 minus 5x squared multiplied by 1 plus 2x. So let's start with this. So in this case, we have y to be equal to x squared into bracket 1 plus x, everything raised to power 3. So what are we expected to do here? No, let me start with, let's start with this first one, because this one will involve the knowledge of function chain rule. 4 minus 5x squared into bracket 1 plus 2x. So let me start with this first one. Then we'll take another one there before we take the one that is a bit advanced. So let's say y is equal to x squared into bracket 1 minus 4x So this is what we do. You call the first one. You can denote this as U and the second as V. That is, we now have U to be equal to x squared. So that we have du dx to be equal to 2x. That's what we have. Then V, the second one, is represented as 1 plus x cube. Okay. So if that is, no. We've decided to change that. So A, y is equal to 4 minus 5x squared into bracket 1 plus 2x. That's what we are given. So we denote the first one as U, then the second one as V. So that U is equal to 4 minus 5x squared, then V is equal to 1 plus 2x. That's what we get. So du dx will be equal to, differentiator of a constant is 0. Then if you want to differentiate this, 2 times 5, that's minus 10x. So dv dx will be equal to, differential of constant is 0, is equal to 2. So therefore, the y dx is equal to u the v dx plus v the u dx. Okay. Then what is u? U is given as 4 minus 5x squared multiplied by dv. dv dx is 2 plus v. V is 1 plus 2x. 1 plus 2x multiplied by du dx. Du dx is minus 10x. So we open up, we expand. 2 times 4 is 8 minus 2 times 5, 10x squared. Then in this case now, we use minus to multiply plus. Minus 10x times 1, that's minus 10x. Then minus times plus, that's minus. That will be minus 20x squared. So if we simplify further, we are going to get this dy dx. dy dx will now be equal to, let's see the constant. This is 8, then minus 10x minus 30x squared. And that will be the value. So that will be the final answer that we are going to arrive at. So if you do that correctly, we are going to get our dy dx to be what we have on the board. So we go ahead and solve the second one. The second question, B, is equal to, where we have y is equal to x squared into 1 plus 4x. That's the second one. So if you want to do this also, we do the same thing. This is y is the product of two functions. So we call the first one u. We represent the second one as v. So that u is equal to x squared. Du dx will be equal to 2x. Then v is equal to 1 plus 4x. Then dv dx. dv dx will now be equal to, dimension of vectors is 0. It will be equal to 4. So finally, the y dx will be equal to u dv dx plus v du dx. That's what we are going to get. So u, in this case now, u is equal to x squared. dv dx is 4 multiplied by 4 plus v. V is equal to 1 plus 4x. Then du dx is equal to 2x. So if we expand this, we are going to have 4x squared. This will be 4x squared plus 2x plus 8x squared. Finally, our dy dx will now be equal to 4x squared plus 4 plus 8, that's 12x squared plus 2x. And that's what we are going to get. So if you have the product of two functions, then you go ahead and use the derivative of derivative of product, or what is called the product rule. So it depends on the nature of the textbook. Some textbooks refer to it as product rule, and in some textbooks you just see derivative of a product. So that is what you are expected to do. So let's take one more example under this product rule. So let's say example 2. So we should find the derivative. Let's find the derivative of A. We want to find the derivative of y is equal to x squared into bracket 1 plus x all raised by half. Then B. So that's what you want to do. B Let's find y is equal to 2x plus 3 squared into bracket 4x squared minus 1 raised power 2. So this is what we are given. So how do we solve this? So if you are given something like this now, you see, there's a way you do function of a function directly. Under function of function, when you have a function, I just want to I want to do a recap before we solve this. If you have y is equal to maybe 2x squared plus 3, everything raised to power 3. In other function of function, you represent the core, what you have inside, as u, so that you will now say dy dx is equal to dy du multiplied by du dx. But what I'm trying to say is that we can actually get the differentiation directly. This is what you do. Differentiate what you have inside the bracket. If you differentiate this now, we are going to have 4x. Now use it to multiply. When you do now take the derivative of this, 3 will come down into bracket 2x squared plus 3 raised by 2. Then at the end of the day, your answer will be 12x into bracket 2x squared plus 3 all squared. So if you do it directly, it's still the same thing. That is dy du. Everything in this bracket will be 3u. That will be 3u squared. Then differentiate. That is how to go about it. So we can actually get that function of a function. We can do it directly without going through any process. Y is equal to x squared 1 plus x raised by half. So in this case now, we call this one, we represent this as u, the second one as v. Now, u is equal to x squared. What is du dx? Du dx is equal to 2x. It's very simple and straightforward. Then v is equal to 1 plus x raised by half. So dv dx now, in this case, of course, we are supposed to use a function of a function, but we can do this directly. What do? Differentiate what you have inside the bracket, which is core. In this case, it's just 1. It is 1. Then you not differentiate everything. That will be half into bracket 1 plus s, everything, half minus 1 minus half. At the end of the day, you have it to be 1 plus x raised by minus half all over 2. And that's same thing as 1 all over 1 plus x raised by half. That's what you are going to get. So finally, dy dx will now be equal to u dv dx plus v du dx. So in this case, our u is x squared multiplied by dv dx is 1 all over 2 into bracket 1 plus x raised by half. Then plus v. V is 1 plus x raised by half multiplied by du dx. Du dx is 2x. So if we now open up, we are going to have this to be equal to x squared all over 2 square root of 1 plus x is still the same thing. Plus, in this case, we have 2x square root of 1 plus x all over 1. And that's what we are going to get. Of course, you might try to leave your answer at this point. Or if you feel like you want to simplify further, then we continue from there. We might try to stop our answer at this point. But if we don't want to stop, then we can continue. We can continue to simplify further. That is, I can go ahead and take the LCM. If I take the LCM here, I'm going to have 2 square root of 1 plus x. So this and this, I'm going to have x squared at the numerator plus, at the end of the day, 1 into square root of 1 plus x. That is 2 times 2. I'm going to have 4s into bracket square root of this will give me 1 plus x. That's what I'm going to get. Then from there, I can open up. From there, from here, I can start to open up. From here, I can decide to open up so that dy dx will not be equal to x squared plus 4x plus 4x squared all over 2 square root of 1 plus x. And that's same thing as, so 4x squared plus x squared, that's 5x squared plus 4x all over 2 square root of 1 plus x. So that will be the value. That will be the final answer for our dy dx. That's what we are going to get. So we now take the last example. we take the last example before we call it a day. So if you have any question under the product rule or what is called the derivative of a product, you can just write it at the comment section. I promise to go over it and get you the solution. B, the second, this is represented as U, and this is what V. So I will say from then I would say U is equal to 2s plus 3 all squared, so that I can do the U dx directly. Of course, I'm supposed to use function of function here or chain rule, but since I have an idea of function or chain rule, I can go ahead and do it directly. The first step is that I will differentiate what I have inside the bracket, the core. If I do that, it is 2. Multiply by, I will now do the derivative of, I will now find the differentiation of everything. The 2 can come down. We have 2x plus 3 minus 1. That is just what we have. Then at the end of the day, 2 times 2 is 4. So I can even get the answer. This is 4. 4 times 2, that will be 8x. So this is going to give me, I'm going to get 8x here plus 4 times 3, 12. That's what I'm going to get. Then V is equal to 4s squared minus 1 all squared. So dv dx will be, I will differentiate what I have inside the bracket. That is 8x multiplied by, let me now take the derivative of this, 4s squared minus 1. That's what I'm going to get. At the end of the day, I'm going to have 16x into bracket 4s squared minus 1. So I might try to expand everything. Then I'm going to add 16 times 4, that's 64 s cubed minus 16x. That is value of my dv dx. So finally, the y dx will now be equal to u dv dx multiplied by v du dx. So u in this case is 2x plus 3 all squared multiplied by dv dx. dv dx is 6s cubed 64. Or let me just use what I have here, so we can still have something that will be common. So let me use this value. 16, that is u is 2s plus 3 all squared multiplied by the v dx is 16x into bracket 4s squared minus 1, then plus v is equal to 4s squared minus 1 all squared multiplied by du dx. So in this case now, du dx is equal to 4 into bracket 2x plus 3. That's what we get. That's what we are going to get there. So from this point now, let's look at what is common. 2x plus 3 is common. So I'll bring one out, 2x plus 3. Then into bracket 4x minus 1 is also common. Then what do we have left? We have 2x plus 3 multiplied by 16x plus, in this case now, we have taken this out, plus 4 into bracket 4x squared plus 1. That's what we are going to have. If you collect the like times, yeah, this is common. We brought out one of these. So we are left with one of these and 16x. So here we are left with one of these and 4. So from there, we now have, I can expand here. 16, that will be 32x squared plus 48x plus 16s squared plus 4. Then also I can have 12s squared here minus 2x plus 12x minus 3. So that at the end of the day, I'm going to have 12s squared plus 10x minus 3 into brackets. I collect the like times here. I'm going to have 48s squared plus 48x plus 4. So I can try to leave my answer at that point, or I can try to simplify further. So I might try to leave my answer at that point. And if I like, I can try to simplify further. I continue with the cancellation until I have the final answer. But I would rather advise that we can stop it at this point. So if you're able to do it to this point, at least you're going to get a full mark. And if you are not satisfied, you can just go ahead and say 12 times 48 x squared times x squared. Then you get your answer in form of x squares, blah, blah, blah. So I would love to stop at this point. So I want to say that if you have any further question on the derivative of a product or product rule, you can just write at the comment section. I promise to check the comment section and provide answer to any question raised at the comment section. Thank you for listening and God bless you all.